Hello everyone, am I audible? Am I audible to all of you?
Yes, sir.
Good, right. Let us wait for 1-2 minutes before the start of session.
कॉल ओवर इंटरनेट करती ना।
Hello Aniket. Okay, let us start. So let us first of all start with the basics of numbers, the definitions of numbers, because these are very important. We must know what are natural numbers, what are whole numbers, integers, etc. Reason being, when you come across the questions, if you just change the variety of the or category of the numbers from, let's say, natural number to whole number, or from whole number to integers, or from integers to rational numbers, the answers will change. Definitely they will change. So first of all, let us start with the basic definitions of numbers. The first part is natural numbers. So we all know that numbers which are used for counting, they are called the natural numbers. So 1, 2, 3, 4 up to infinity, they are all called the natural numbers. Right, natural numbers or positive integers. So normally 1, 2, 3, 4, 5, etc. All these are natural numbers. And what are whole numbers? If we just add 0 to the set of natural numbers, if we add 0 in the set of natural numbers, what we will get is the set of whole numbers. So we can say that 0, 1, 2, 3, all these numbers, they are called the whole numbers. So I can say that set of natural numbers is contained in the set of whole numbers, or set of natural numbers is a subset of set of whole numbers. That means every natural number is a whole number, but the converse to this is not true. Every whole number is not a natural number. And after that, if we talk about integers, then we say that if I take the whole numbers and negative of the whole numbers also, the set that we will get is the set of integers. So whole numbers, I know that they are 0, 1, 2, 3, etc. So these are the whole numbers. And if I take the negatives of these numbers also, so if I'm taking 1, if I take -1 also with 2, if I take -2, -3, etc. also, then the set will be the set of integers. So when it comes to integers, generally what happens that we think about only the positive numbers. Whenever the question says that x is an integer, so we generally think that x is 1, 2, 3, 4, 5. But that is not the case. X could be the negative integer also, it can have the negative value also. So instead of just going with the 1 2 3 etc., you must also think the negatives whenever the question says that x is an integer. So again, we can say that since we have taken, to get that set of integers, we have taken all the whole numbers and we have taken the negatives of those whole numbers also. So we can say that every whole number is an integer. Every whole number is an integer, but converse again is not true. Every natural number is a whole number, every whole number is an integer, right? But converse of these statements is not true. Every whole number is not a natural number, and every integer is not a whole number. Moreover, when we talk about integers, then we also come across two different or two subsets of integers. One is the positive integers. Obviously, positive integers are 1 2 3 and so on. And next come the negative integers. So negative integers are -1, -2, -3. Now why they are important? Because many a times now what happens in the paper, that examiner does not use this word natural numbers or the whole numbers, right? These are uh, conventional way to address the numbers. So normally what happens, examiner does not use or rarely use these type of nomenclature. Now what they use is positive integers. So whenever it comes to the positive integers, that means he is talking about the natural numbers 1 2 3 4. So whenever the question says that x is a positive integer, that simply means that x is a natural number. And also, now there are two things. When it says positive integers, 0 is not included there, because 0 is neither considered as positive, right? Not it is not considered as positive, or nor it is considered as negative. So 0 is a neutral number. It is not positive nor negative. So when we talk about a positive integer, 0 is not included. And when the sentence says non-negative integers, non-negative integers. So non-negative integers means that integer should not be negative. So since 0 is not negative, so here what we say that the numbers include are 0 1 2 3 4 and so on, means set of whole numbers. So basically set of whole numbers is also called the non-negative integers. So when the word positive integer is there, you will be looking for the natural numbers only. When it is non-negative integers, the numbers are whole numbers, because 0 is not a negative number. Only difference, there's a difference between positive integers and non-negative integers. When we say positive integers, 0 will not be the part, but when we say non-negative integers, 0 will be the part of the set. Is that clear up to this point?
Yes,
Then
sir.
we have negative integers. Obviously, -1, -2, -3, they are the negative integers. And this non-negative part we already discussed, that this is also called the whole numbers 0 1 2 3 and so on. All these are non-negative integers, right? Next is the prime numbers. So those numbers which have exactly two factors, they are called the prime numbers. Here it is written that which are divisible by 1 and numbers itself, they are called the prime numbers. But this is a little bit, you can say, incomplete type of definition, because if you go with this definition, then 1 will also be a prime number if you go with this definition. So actual definition is numbers which have exactly two factors, they are called the prime numbers. So numbers which have exactly two factors. After that, you can say that those exactly two factors, they are 1 and the number itself, but they should have exactly 2, right? So that's why 1 is not considered as the prime number, since 1 has only one factor. 1 is divisible by 1 itself only, so 1 has only one factor. But for to qualify for the category of prime numbers, a number should have exactly two factors, 1 as and the number itself. And the least prime number is 2, and 2 is the only prime number which is even, as 2 can be divisible by 1 only, or 2 can be divisible by 2 only. So 2 is divided by only 1 and 2, so 2 is also a prime number. And apart from 2, no other prime number is even. 2 is the only prime number which is even, as well as the smallest prime number. And these are the first 25 prime numbers up to 100. There are 25 prime numbers up to 100. From 1 to 100 we have 25 prime numbers, 2 3 5 7 11. And whenever you are preparing for any competitive exam, you must be aware of these 25 numbers. You must learn these first 25 prime numbers by heart. The reason being, they are the most widely used. And moreover, in the exam we do not have time to check whether a given number is a prime or not. Let's say you are having 41 or 73, or let's say 89 with you. So it is not advisable to check at that point of time in the exam that whether these numbers are prime numbers or not, because that will take a lot of time, and the time is the key in the exams. So you must remember all these prime numbers as they are important. They will be used again and again in the questions. Moreover, any prime number greater than 3, now this is important, any prime number greater than 3, whenever you have prime number greater than 3, that can be written as 6k plus 1 or 6k minus 1. So any prime number which is greater than 3, that can be written as either 6k plus 1 or 6k minus 1, where k is a natural number. That means any prime number can be expressed in this form, either 6k plus 1 or 6k minus 1, but that prime number should be greater than 3 only. Just take an example. Let's say 11. So we can write 11 as 6 into 2 minus 1, which is 6k minus 1. This is the form 6k minus 1. Let us take 23. 23 is nothing but 6 into 4 minus 1. Let us take 31. 31 is nothing but 6 into 5 minus plus 1. So any prime number can be written either in the form 6k plus 1 or 6k minus 1, right? But that prime number should be more than 3, greater than 3. But converse of this result is again not true. Now, what does that mean? It means a number which can be written as 6k plus 1 or 6k minus 1 form, that need not to be a prime number. Prime number can be written as 6k plus 1, prime number can be written as 6k minus 1. But if a number is written as 6, if a number can be written as 6k plus 1 or 6k minus 1, then that number need not to be a prime number. Is my voice audible? Am I audible to everyone?
Yes, sir.
Wait a minute, please. So what I was saying is, if a number can be written as 6k plus 1 or 6k minus 1, then that number need not to be a prime number. For example, 25. 25 can be written as 6 into 4 plus 1. Again, this number can be written as 6k plus 1, but this is not a prime number. 77. 77 is 13 into 6 minus 1, or 6 into 13 minus 1, let's say. This is 6k minus 1 form, 77. 77 is 6k minus 1, 6 into 13 minus 1. So this number is also not a prime number. So prime numbers are those which can be written as 6k plus 1 or 6k minus 1, but it is not the other way. It is not that every number which can be written as 6k plus 1 or 6k minus 1, that need to be a prime number. And the composite ones, they are the numbers which have factors, which have more than 2 factors, right? So for example, if you exclude all the prime numbers and 1, all the given numbers, all the remaining numbers will be the composite numbers. 1 is neither prime nor composite. Reason being, To qualify for the prime numbers, it should have exactly two factors, which is not there. And for the composite numbers, it should have more than two factors, which is again not there. So one is not considered as prime or composite. Rational numbers, number which can be written as P over Q form, they are called the rational numbers. So if you are able to write down a number in the form P over Q, then that number is called a rational number. If a number is of the form P over Q, that will be considered as the rational, but condition is that P and Q, they are integers. P and Q are integers and Q is non-zero. So for example, 2 by 3, 5 by 12, minus 7 by 8, all these are rational numbers as they are written in the form P upon Q. Now, why this minus 3 is a rational number? It is also written minus 3, 0, etc. Why these are rational numbers? The reason is minus 3 can be written as minus 3 upon 1. It can be written as minus 3 upon 1. So again, it is P over Q form. That's why it is also a rational number. So I can say that minus 3, I know that this is an integer. So an integer can also be written as P over Q form. That means every integer is again a rational number. Every integer is a rational number. And for the rational numbers, we have two more subcategories. One is the terminating decimal. So whenever we have a terminating decimal, that terminating decimal can be converted into a rational number, or that can be converted into P over Q form. Whenever we have a terminating decimal, that can be converted into P over Q form. Right. So terminating decimal means that decimal which terminates, which ends somewhere. For example, if I take the simple example of, let's say, 0.125. Now this is a terminating decimal. 0.125 is a terminating decimal. I can write this number as 125 divided by 1000, which is nothing but 1 by 8. So 1 by 8 again is a rational number. It is written in the form of P over Q. So whenever we have a terminating decimal, that can be converted into a rational number. Further, second part, if we have non-terminating recurring decimals, then that number can also be converted into a rational number. Non-terminating recurring decimal. Now what does it mean? Non-terminating means the decimal is not going to terminate anywhere. It is a never-ending decimal, but recurring, repeating. So digits that are being used to write that decimal, they are repeated, they are recurring after a certain time. They are actually following a certain pattern. So if such kind of number is there, or decimal is there, that can also be converted into a rational number. For example, we know that if I write down here 1.333333 and so on. So this is a never ending decimal. This is a non-terminating but recurring decimal. Recurring means the digit that is being used after decimal, which is being repeated, that is occurring with the particular pattern here. So 1.3333 and so on. Right. So this is a non-terminating recurring decimal, and we know that its value is nothing but 4 by 3. It is actually 4 by 3. So 4 by 3 is again P over Q form. So it is a rational number. So every non-terminating recurring decimal is a rational number. And this is the basic difference when we call about the rational and the irrational numbers. The only difference is that in case of irrational numbers, the decimal is infinite non-recurring. Infinite means non-terminating. Infinite means non-terminating. That means again the decimal is not terminating, but non-recurring means now the digits which are being used to write down that infinite decimal, they are not following any particular pattern. You cannot guess which digit will be the next one. So such a kind of numbers, they are called the irrational numbers. So examples are there on the screen: under root 2, under root 5, pi, etc. So if you are having a non-perfect square, then square root of those numbers. If you have non-perfect cubes, then the cube roots of those numbers, and so on. All these are irrational numbers whose value can be a non-terminating decimal, but the decimal digits in that decimal will not be the ones which are following a certain pattern. So is that clear up to this point? Before we move further, just let me know, are these definitions clear to everyone? So then it comes the real number. So whatever we have discussed in the previous slides, all the categories of these numbers, if I combine them, if I write down all the categories in just one set, then that set is called the set of real numbers. When we talk about the real numbers, then real number include every type of number, whether it is a natural number, it is a whole number, it is a integer, rational, irrational. All these categories are categorized as one super category, that is called the real numbers. Let us now do one simple question. Which of these cannot be the sum of consecutive prime numbers? So you have 4 options with you. You need to answer that option which cannot be written as the sum of consecutive prime numbers. In the bracket, it is written that at least 2 prime numbers to be used. Now remember, it says at least 2 prime numbers. It's not saying that exactly 2. At least 2 means you can use 2 prime numbers, you can use 3, you can use 4, you can use n number of prime numbers, but those prime numbers should be consecutive. So which among these 4 options cannot be written as a sum of the consecutive prime numbers? And if you are not aware of the prime numbers, if you do not know all the prime numbers up to 100, let me once again show you the slide, and just take the screenshot of this slide so that it is easier for you people to answer this. So here are the first 25 prime numbers. Just take the screenshot. And it will be good if you people participate in the discussion also. It should not be a one-way conversation. It would be a healthy conversation if it is both way. So you people can unmute yourself whenever you are answering the question, or you can also type the answer in the chat box, but it should be a two-way communication. So shall we move further now?
Yes, sir.
Now answer this one.
$17.
Okay, Manan. Okay, Manvi. Remember, at least 2 prime should be used. It is not saying that exactly 2. You can use 2 prime numbers, you can use 3 prime numbers, 4, 5, any number of prime numbers, but they should be consecutive ones. Okay, what do you think? Which 2 consecutive prime numbers will add up to 52? Which 2 consecutive prime numbers will add up to this number? Okay, Ishan, you okay? Manan, actually, you should use 2 consecutive prime numbers.
23 and
Actually, these are not the
29.
consecutive ones. Just again go through this slide. So if you want to note down these on your notebook, you can take that time also. If you are using 11 and 41, no doubt those 2 are prime numbers, but they are not the consecutive ones.
So 23 and 29.
Very good. Right, Ishan Pratap Singh. Yes, it is 23 and 29. Good. So you can write 52 as a sum of two consecutive primes. What about this number? A few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. So I have written some of the prime numbers. So what do you think? 17. Isn't the 17 is the sum of 2, 3, 5 and 7? If I use the first four prime numbers, they are the consecutive ones. Isn't
Yes,
the
sir.
17 sum of all these?
Yes, sir.
Yes, good. Right. So 17 can also be written as the sum of two consecutive prime numbers. What about 42? Forty-two.
So 23 and 19.
23 and 19. Very good. It is a sum of 19 and 23. So that means the first three options, they can be written as the sum of consecutive prime numbers. So
Yes,
answer
sir.
has to be option 4. 14 cannot be written. So 14 can be written either adding 3 and 11, right? 3 and 11 are prime numbers. That can be done, but the problem is 3 and 11, they are not the consecutive primes. Or 14 can be written as 2 plus 5 plus 7 also. 2, 5, 7, that is again not a prime number. The consecutive prime number, sorry. Although they are prime numbers, but not the consecutive ones. Reason being 3 has been missed.
Yes, sir.
Uh, if you take 37 plus 3 plus 2, no doubt prime numbers are there, but again, they are not the consecutive prime numbers. So is the concept of consecutive prime numbers clear? Although these are prime numbers, but they are not consecutive ones. Consecutive means 2, 3, 5, 7. They are in order, one after the other. Okay.
Okay, sir.
Let us now solve this one. What is the smallest integer with which this number should be multiplied so that it becomes an integer? 23 by 99. We have this fraction 23 by 99. Ishan, that you will get information about that. Just contact the admin team. That will depend upon the batch. Okay, please answer this one. You have this fraction with you. What smallest number is required with which it should be multiplied so that it becomes an integer? Okay, Manan. No answer? Okay, what will happen if I multiply it by 99? This you can answer. If I multiply 23 by 99 by 99, what should be the answer? What should be the value? Yes, it is 23. Do you get this now or not? The question is saying, what is the smallest integer? So is it that the answer is 99? Okay, what will happen if I multiply it by 0? What will happen if I multiply it by 0?
It will become 0.
It will become 0. Isn't 0 an integer?
Non-negative integer.
Nowhere it is written non-negative integer. Actually, important is smallest. Question is asking for the smallest integer. So smallest cannot be 99.
Yes, sir.
Smallest cannot be 0. Why? When you multiply it by 0, no doubt you are getting 0, which
0.
is an integer, right? But what will happen if I multiply this by, say, minus 99? Again, I told you, when you have integers, not only the positive integers are there are also negative ones. If I multiply it by minus 99, its value will become minus 23. So isn't minus 23 an integer? Yes, definitely.
Yes, sir.
So that means it should be minus 99. Can you think about some other numbers also? Okay, Ishan, you tell me. What about minus 198? Actually, what is required? That is important. You have 23 by 99. In order to convert it into an integer, this fraction should be removed. This denominator part should be removed. That means this fraction should be multiplied by a multiple of 99. So whenever you take a multiple of 99, this fraction will be removed. This fraction will be removed. But problem is, it is asking for the smallest integer. So 198 is a multiple of 99. So just take the negative of 198. This will give you minus 46. Again an integer. If you take the third multiple of 99, which is 297, negative of that, this will give you, this cancels at 3. So this will give you minus 69. This is again an integer. So you cannot say that answer is 99 or 0 or minus 99 or minus 198. So what do you conclude from this discussion? Can you tell me now? Now it is easy to conclude. Okay, I told you that this is good if you people participate in the discussion. Even if you do not know the right answer, just make the guesses. No problem in that also. What will happen? Answer गलत हो जाएगा और क्या हो जाएगा? कोई problem नहीं है. So can I
Minus
take a
891.
smaller number? Minus?
891.
But if I multiply it, let's say, by minus, say, 99 and added endless zeros, infinite number of zeros, still I will be getting an integer?
Yes, sir.
Answer is cannot be determined. You cannot find the smallest integer. You cannot find the smallest integer. Is that clear?
Yes, sir.
And if I change the category of number from the integer to smallest natural number, then answer would have been 99. The reason being, we cannot take 0. 0 is the whole number, not a natural number. We cannot take negatives also. In that case, the answer would be 99. So if you change the category of numbers from natural number to integers, from integers to whole numbers, if I take whole number, smallest whole number, in that case, answer would be 0. So it all depends upon the type of numbers which are given to you in the question. You cannot ignore the type of the numbers. For the same question, you have 3 different answers. If you just change the variety of the integers, just take the natural number, answer would be 99. Take whole number, answer is 0. Take integers, answer becomes cannot be determined. I think this is now clear. Any doubt in this one, please, you can ask me. And please do participate in the discussions. Amanpreet, Anamika, Anuj, Ashit, Athrav, Harsh, Ajasvi, Sameer, Saurav, please. Let us now move to the next one. Now think about this number, this question again. Product of 2 integers is 28. What will be their minimum possible sum? Okay, Manan. It's saying that product of 2 integers is 28, not the sum of 2 integers. Product of 2 integers is 28. What will be their minimum possible sum? Very good, Anuj. Okay, Ishan. Ishan, again, the question is asking for the integers. Right, Saurabh? Product of 2 integers is 28. So if you are taking 7 and 4, that will give you 28. And their sum is 11. No doubt in that. But this would be your answer if I change the category of the numbers from integers to natural numbers. If I take them to be natural numbers, then answer would have been 11. But this is not the case here. It says product of 2 integers. So when it comes to the integers, you can also take negatives.
Minus 29.
Yes, you can take -7 and -4. That will again give you 28. Sum would be -11. But if you have to minimize the sum, it is good if you take the negative of this number 28. If you take -28 and -1, that also will give you 28, and the sum in that case would be -29. This would be your answer. Just think about the numbers. It says 2 integers, product of 2 integers is 28. And since the minimum sum is asked from you, that's why you must take one number which is as small as possible. And as you need to get the product 28, so you cannot go below 28. You must take one number as -28 and other one as -1. Did you get this?
Yes, sir.
And obviously for natural numbers, if I write natural numbers here, the answer would be 11. In that case, the numbers will be 7 and 4. You cannot go below 7 and 4. Answer would be 11 in that case. And what will happen if instead of integers or natural numbers, if I write just numbers, if I write product of two numbers is 28, what is their minimum possible sum? So what do you think the answer should be in this case?
C and D.
Very good. Yes. Because now again, when it comes to the numbers, that means you can take rational numbers also. When I write integers or the natural numbers, rational number will not come into play. But now you can also use the rational numbers. So although in the previous example, we just stopped at this point. But when it comes to the numbers, that means we can also take the fractions now. We can also use the rational numbers. That means I can also write like this, minus 56 into minus 1 by 2. This will again give me 28, but sum in this case would be minus 56.5, which is lesser than or minus 29. Right, so we can use the fractions now. What will happen if I write minus 28 and put infinite number of zeros with it, multiplied by minus 1 by 2, and with 2 in the denominator, I can put as many zeros with 2. Again, I will get the answer 28. But in this case, the sum is very, very small. So again, if I take just numbers, answer is cannot be determined. Okay, now try this one. Product of three distinct integers is 24. What is their minimum possible sum? No, Anuj. So here we have the product of three distinct integers to be equal to 24. So either I can take all the integers to be positive, but since the question is asking for the minimum possible sum, that means I need to think about the negative integers also. But as the product is 24, what I can do, I can take two integers negative and one as a positive. I can take two negative integers and one positive. Again, the logic is same as we did in the previous one. Since I need no Ishan, no Thrav, no Anuj, we need the right sort of. We need the smallest sum, minimum sum. So I should take one number as small among these three integers. I should take one integer as small as possible. I should take one integer as small as possible, Ishan. So if you are taking minus 2, minus 4, 3, although it will give me 24, but it will not give me the minimum sum. I told you in the previous question also that you should be thinking about the numbers on the lowest side. As the product is 24, I can take one number as minus 24. I can take the second one as minus 1. third one as 1. Sum is 24. So what is, product is 24. So what is the sum here? Minus 24 minus 1 plus 1. It should be minus 24. Is that clear? Just try to think about the numbers. Any doubt in this one, you can please ask me. Okay, if the sum of 3 integers is 24, what will be their maximum possible product? Now, this is a different question from the previous one. In the previous question, product of 3 integers was 24, minimum sum was asked. Now here sum is given to you and maximum product is asked. Ishan, in the previous question, in this one you are asking for the maximum sum. For maximum you can take 24, 1 and 1. But since distinct integers are asked to you, so that will be 12 into 2 into 1 for the maximum one. So maximum would be 15. Right, Anuj? Yes, sir. What is your doubt? Uh, yes, you should answer it first of all, Ishan. Try it. We will discuss it. And Harsh, what is your doubt? You can unmute yourself to explain your doubt. No, 12 to 1. Not 12, 1, 1, 12 to 1. Actually, I was writing 24 into 1 into 1. But since the integers were distinct, I cannot take two ones. That was for the previous question, not for this one. So in this case, it is saying that sum of 3 integers is 24. What should be the maximum possible product? We have 3 integers whose sum is 24. What should be your approach? Obviously, if the maximum product is asked, then that product should be positive. That product will be positive. I am interested now in the positive product. We need a positive product now. No, Harsh, not prime numbers. Okay, I can take one number, let's say No, Jagannath, that is AMGM will be applied only if you have positive real numbers, not for integers. In integers, you can take the negatives also, or you cannot take the fractions, but we use the concept of AMGM only if we are given positive real numbers. Yes, that can be done, Saurabh. But what if I take, let's say, x to be a very large number, or let's say x is 800. Let us take x to be 800.
Okay.
And say y is minus 400. And z is say minus 376. Still your sum is 24.
Yeah.
And what will be the product? Obviously, product is very large.
Very large.
No, it will be positive. 800 multiplied by minus 400 multiplied by minus 376. You will get a very large product. And I can manipulate these numbers again. I can take one value of x very large, let's say in lakhs. Correspondingly, I can take two values for y and z in such a way they are negative and their sum becomes 24. Can I do that?
Yes, sir.
Yes, sir.
Let's say I'm taking one number to be, let's say 1 lakh. X is, let's say 1 lakh. Y is say minus 50,000. Z is say minus 49,976. Their sum is again 24. So product is very large now. That means we can manipulate the numbers according to our needs. So answer again is cannot be
Safety.
determined. We cannot find the maximum possible product. Is that clear?
Yes, sir.
And if I take, instead of integers, if I take natural numbers again here, so in that case, what would be the answer for natural numbers? For natural numbers. Now, if the numbers are natural numbers, I cannot go with the negatives. Obviously, I cannot go with the negatives in that case. In that case, the product will be maximum. You have the sum of three numbers, 24, constant, sum is constant. So product will be maximum when the three numbers are as close as possible. In this case, product will be maximum if x, y, z, they are as close as possible. If difference between x, y, z is minimum, it should be if difference between x, y, z is minimum. Okay, in that case, you will get the maximum product. That will happen if, let's say, all of them are equal. So if we take x, y, z as 888, in that case, the product will be maximum. So maximum product in this case would be 8 multiplied by 8 multiplied by 8, which is 512. So if I take natural numbers for this question, answer would be 512, but for integers, it will be cannot be determined. See. Any doubt up to this point, you can please ask me. Let us skip this one now. N is a positive integer, then 3 raised to power 4n minus 4 raised to power 3n is always divisible by.
17.
Sorry, sir. So can you answer again? Yes, good. N is a positive integer. That this number is always. Now here important is always. Means you need to get you need to mark that answer which is true for every n. What is the simplest way? N is a positive integer. Okay. So what you can do is you can take n as 1. Positive integer means n is a natural number. So you can take n as 1, 2, 3 and so on. Let us take n to be 1. क्या बनेगा? 3 power 4 minus 4 cube. This will be 81 minus 64, 17. This is the smallest number among the given options. Apart from this 7, 7 cannot be the answer. Obviously, 7 does not divide 17. If we take the smallest positive integer, we will get the smallest value, which is 17. So now 17 is divisible by 17. That simply means that answer has to be option 2. Is that clear? Is it clear? Shall we move now?
Yes, sir.
Let's leave all these questions because we have done a lot of among them. So what is the sum of odd numbers up to 600? So do you know the formula for this? Sum of odd numbers up to 60. So not 600, 60. Okay, the sum of first n natural numbers. Sum of first n natural numbers is given by n into n plus 1 by 2. Sum of first n natural numbers means starting from 1. So if someone asks me that what is the sum of first 50 natural numbers, so I have 1, 2, 3 up to 50. Sum of these 50 natural numbers, and the value for n is 50. So answer would be 50 into 51 by 2. Cancel this one. So answer comes out to be 1275. Right. So this is a sum of first n natural number, n into n plus 1 by 2. Similarly, if we have sum of squares of first n natural numbers, sum of squares of first n natural numbers, that becomes equal to n into n plus 1 into 2n plus 1 divided by 6. N into n plus 1 into 2n plus 1 divided by 6 if the squares are there starting from 1. Similarly, for the cubes, sum of cubes of first n natural numbers will be equal to n into n plus 1 by 2 whole square. So let's say if question says that what is the sum of cubes of first 10 natural numbers, sum of cubes of first 10 natural numbers, so answer would be directly 10 into 11 by 2 whole square, means 55 whole square. That becomes 6 5s are 30, so 3025. So these are the basic results. You must be aware of these results. This also, but the question is a little bit different here. Sum of first n odd natural numbers, sum of first n odd natural numbers, that is given by the result n square. No, Manvi, sum of first n odd natural numbers is given by the direct result n square. The sum will be n square directly. Sum of first n odd natural numbers is n square. Similarly, you can also write down this result. Sum of first n even natural numbers. If we talk about the evens only, not the odds, but even natural numbers, that is given by n into n plus 1. Sum of first n even natural numbers is given by n into n plus 1. So obviously question is asking for the sum of the odd natural numbers up to 60. So the formula that will be used is the this one, which is n square. So what should be the answer? Now only the application of this formula is left for the answer. You can directly answer that now. How many natural numbers are there which are odd up to 60? Or how many odd numbers are there up to 60? Yes. Answer it. How many odd numbers are there up to 60? When you write down all the numbers up to 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, can I say that half of them will be even and half of them will be odd? If we write down, right, Ishan, if we write down all the natural numbers up to 60, half of them will be even and the other half will be odd. Yes, right, Ishan. So how many odd natural numbers are there up to 60? There are 30 natural numbers. So basically question is sum of first 30 odd natural numbers. So sum of first 30 odd natural numbers will be 30 square or 900. Right, so answer is option 2. So p is a prime number greater than 5. What is the remainder when p is divided by 6? Right, Manav, Manan, no Manvi. P is a prime number greater than 5. Just take the examples. Just consider any prime number greater than 5. Let's take 7. What is the remainder when 7 is divided by 6? It is 1. But if I take the prime number 11 divided by 6, what is the remainder? No, Harsh. If I take the prime number to be 11, divide this by 6, what is the remainder in that case? Remainder will be 5. Answer has to be option 3. Remember, I told you that a prime number can be written as 6k plus 1 or 6k minus 1. If it is of the form 6k plus 1 divided by 6, now this 6k is divisible by 6. What is left is 1. So 1 divided by 6 will give you remainder 1. On the other hand, if it is like 6k minus 1 divided by 6, 6k divided by 6 will give you no remainder. So minus 1 divided by 6 will give you remainder as minus 1. Since the remainder cannot be negative, you can add 6 to get the positive remainder, which is 5. So answer either is 1 or 5. It has to be option 3. Very good, Jagan. Did you get this now? Okay, test of divisibility is now. A number is divisible by 2 if the unit place is 0, 2, 4, 6, 8, etc. So we know that is not much difficult to know the divisibility of 2. In fact, what happens is 2 is nothing but 2 is 2 raised to power 1. So since the power is 1, what we do is we take the last digit. So if the last digit is 0 or it is 2, 4, 6, etc., then number is divisible by 2. 4 is 2 square. Since 4 is 2 square, that's why since the power is 2, we take the last 2 digits of the number. Last 2 digits. So if the last 2 digits of the number are zeros or they are divisible by 4, we say that the number is also divisible by 4. For example, if I take, let's say, a number is 2, 3, 4, 5, 6, 7, 8, 4. And I need to check that whether this number is divisible by 4 or not. I will not consider the whole number. I will just check the last 2 digits. Here the last 2 digits are 84. 8 and 4. The number becomes 84. I know that 84 is completely divisible by 4. As 84 is completely divisible by 4, this whole number is also divisible by 4. Right? So this is also divisible by 4. For 4 is 2 square. That's why we take the last 2 digits. Similarly for 8 is 2 cube. Now for this we take the last 3 digits. If the last 3 digits of the number they are divisible by 8 or they are 0, then number is also divisible by 8. So last 3 digits should be 0 or the number formed by last 3 digits should be divisible by 8. Then whole number will be divisible by 8. Now in this case also the last 3 digits are 784 and the number found by these last 3 digits is 784. If you divide 784 by 8, that is completely divisible. 8 nines are 72, 6 is a remainder, so 64, 8 eights are 64. So last number found by the last 3 digits is completely divisible by 8. That's why this whole number is completely divisible by 8. Right? So this will keep on going like this. For 16 is 2 power 4, so you will check the last 4 digits and so on. So that is the rule for 4 is also written here. The number is divisible by 4 when the last 2 digits of the number are 0 or are divisible by 4. Now for 3, the rule for 3 and 9, they are same. A number is divisible by 3 or by 9. Their number is divisible by 3 or 9 if the sum of the digits is divisible by 3 or 9. Let's first of all talk about only 3. A number is divisible by 3 . 7 is just a single digit number, no? Or you can write it as 07, Saurabh.
No, sir, it's a mistake. I was typing something else.
Sorry.
I
Can you
had a
speak?
question. Hello.
Yes. Yes, Saurabh, you can speak. Yes, Saurabh. Okay. So number is divisible by 3 if the sum of digits is divisible by 3. For example, this number is 23,781. Just add up the digits 2 plus 3 plus 7 plus 8 plus 1. The sum becomes 21. As 21 is divisible by 3, this number will also be divisible by 3. Right? For 4, we already discussed last two digits. For 5, we know that last digit should be 5 or 0 to get the number divisible by 5. Next, for 6, number is divisible by 6 if it is divisible by both 2 and 3. If number is divisible by 2 as well as by 3, it will be divisible by 6 also. For 8, we discussed the last 3 digits need to be taken into care. If the last 3 digits of the number formed by the last 3 digits, if that is divisible by 8 or last 3 digits are 0, then number is also divisible by 8. The whole number will be divisible by 8. For 9 again, sum of digits should be divisible by 9. Now here 92754, if you add up the digits here, the sum becomes 9 plus 2 plus 7 plus 5 plus 4. So that will be equal to 11, 18, 23 and 27. Sum becomes 27. As 27 is divisible by 9, this number is also divisible by 9. So number is divisible by 9 if the sum of its digits is divisible by 9. For 11, whether a number is divisible by 11 or not, we can check the digits in the odd positions and the even positions. Just add the digits in the odd positions of the number. Odd position means first position, third position, fifth position, and so on. So, for example, the number taken here is 65,967. So the digits in the odd places are 6, 9, and 7. If you add up all these digits, it will be 6 plus 9 plus 7. The sum becomes 22. Then add up the digits in the odd even places. 5 plus 6, that is 11. Now take the difference of these two. Difference of 22 and 11 is 11. So this difference should be either 0 or a multiple of 11. Only then the number will be divisible by 11. If this difference is 0 or a multiple of 11, then the number will be divisible by 11. In this case, this difference is coming out to be 11. That means this whole number 65,967 is also divisible by 11. Right? This is, let's say, take the number 1331. The digits in the odd positions are 1 and 3. 1 plus 3 is 4. The digits in the even positions are 3 and 1. So 3 plus 1 is 4. And their difference is 0. Since the difference is 0, so this number is also divisible by 11. Right? For 12, the number should be divisible by 3 as well as 4. 12 can be factorized as 3 into 4. The factors are co-prime, means they should not have any factor common in between them. So 12 is 3 into 4. So if the number is divisible by 3 as well as by 4, then we say that it is also divisible by 12. Now, it is not that these divisibility rules are not important. Many times questions are directly asked on the divisibility rules. For example, this one. You have this number. Now, you definitely can find this kind of question in your competitive exam. Question says this number is divisible by 3. How many such numbers exist, given that this hash sign is a single digit that can take any value from 0 to 9? So this question simply is based on the concept of divisibility rule. What was the divisibility rule of 3? The divisibility rule of 3 was that sum of the digits should be divisible by 3 in order to get the number divisible by 3. So here we have 6, 5, 4, 3, 7, hash 5, 2, etc. So what is the sum of the digits here? Just try to find the sum of digits. 6 plus 5, 11, plus 4, 15, 18, 25, 31, 36 and 38. So it is 38 plus hash. Okay, so if I add up all these digits, the sum becomes 38 plus hash. So how many such numbers exist? Now you tell me please, what can be the values for this hash in order to be this number divisible by 3? The rule says sum of digits should be divisible by 3. what are the possible values for hash? Good, Harsh. If I take hash to be 1, it becomes 38 plus 1, 39. Sum will be divisible by 3. So number will become divisible by 3. Are there any other values possible for this one? If I take hash to be 4, then it becomes 38 plus 4, 42. We can take 7 also. 38 plus 7, 45. We can take 1, 4 and 7. 1, not 3, but 4. If I take 3, it will be 48 plus 3, 38 plus 3, 41. Right, we need 42. That means the hash should be 4, or it could be 7 also. If I take 7, it will be 38 plus 7, 45. After that, 10 is required, but hash cannot take the value 10. So only these 3 values for this hash is possible. So how many numbers exist? Only 3 numbers. So only 3 numbers of this type are possible where the number formed will be divisible by 3. So shall we move to the next one now? No problems, Jagan. Now try this one. This number is divisible by 4. So you have to apply that divisibility rule for 4. Hash can take any value from 0 to 9. No, Ishan. Read the question once again. Very good, Saurabh. So divisibility rule of 64 says the last 2 digits should be divisible by 4. Here the last 2 digits already are 64. 64 is completely divisible by 4. That means it will not matter what is the value for hash. This number is definitely divisible by 4. So hash can take any value from 0 to 9. Hash can be 0, 1, 2, 3 and any value up to 9. Right? Number is always divisible by 4. No, Harsh. Number is, this is your number, na? 87649 hash, then 64. Number is divisible by 4 if the last 2 digits, number formed by the last 2 digits is also divisible by 4. In this case, the last 2 digits are 64. 64 is already divisible by 4. That means you can take any value for this hash. The number is going to be divisible by 4. So hash can take 0, 1, 2, 3, 4 up to 9, any digit as its value. Answer is 10 in this case. Hash can take 0, 1, 2, 3, 4, 5 up to 9, any value. Okay, Ishan, but for the previous one also there were 3 values. 1, then it was 4 and 7. Is this question clear now? Shall we move to the next one? Just leave this one, leave it, now try this one. Yes, Ishan. The divisibility rule of 88 is nothing but 8 into 11. It can be written as the product of two factors which are co-prime as 8 and 11. So a number is divisible by 88 if it is divisible by both 8 and 11. This is the divisibility rule for 88, that it has to be divisible by 8 as well as by 11. So we have this number 8A 514 6B. Now this number is divisible by 88. That means it has to be divisible by 8 and 11. The divisibility rule of 11 says, that the sum of digits in the odd places and the even places, they should have a difference of 0 or a multiple of 11. The digits in the odd position are 8, 5, 4 and B. Their sum is 8 plus 5 plus 4 plus B. It is 17 plus B. And the digits in the even position, they are A, 1 and 6. Second digit, fourth digit and the sixth digit. That is A plus 1 plus 6. It is A plus 7. Now difference of these two, odd minus even, is 17 minus 7 will be 10. So 10 plus B minus A. It is 10 plus B minus A. Right? 10 plus B minus A. And this difference should be either 0 or a multiple of 11. So that means difference can only be 11 now. It cannot be 0, right? Because 10 is something is added to the 10. It cannot be 0. And it cannot be 22 also. In order to get 22, मुझे B minus A कितना चाहिए? I need B minus A 12. अगर B minus A की value 12 आएगी, if this value is 12, only then I will get the difference to be 22. But that is simply not possible, as A and B, they are the digits. Their difference cannot be 12. ठीक है जी? Only possibility is that this B minus A can be 1 only. That means the value of B and A, their difference is 1. Is this clear up to this point? Any doubt? You can please ask me. If anyone has any doubt up to this point, please ask me. We just check the divisibility for 11. This number is divisible by 88. Means it has to be divisible by 8 as well as 11. Right? So we check the divisibility by 11 only. Now we need to check the divisibility by 8. Now divisibility by 8 says that the number found by the last 3 digits should be divisible by 8. Here the number found by the last 3 digits is 46B. Okay, Harsh, which part you are not been able to understand, please? Can you tell me the particular point? Question says this number is divisible by 88, right? The divisibility rule of 88 says the number should be divisible by 8 as well as 11. As 88 is 8 into 11, which are the two co-prime factors of 88. So a number, you can say that number is divisible by 88 if it is divisible by 8 as well as by 11. Okay. Now that means this number is still being this number divisible by 88, it has to be divisible by 8 and 11. Now divisibility rule of 11. Did you get that rule? हर्ष आपको वो रूल क्लियर है? Divisibility of 11. Yes. So what we did is we added the digits in the odd positions here. Their sum became 17 plus B, means 8 plus 5 plus 4 plus B. And we found that sum at the even places, A plus 1 plus 6. Right. took the difference of these two, difference becomes 10. Now अगर मैं इन दोनों को माइनस करूंगा तो क्या आएगा? I will get 10 plus b minus a. And the rule says that this difference should be either 0 or multiple of 11. Now this difference cannot be 0. Right? This difference 10 plus b minus a cannot be 0. Write me here, good. Right? This cannot be 0. So it has to be 11. And it will become 11 when b minus a becomes 1. Is this clear now? Harsh, please confirm करो. Yes. So यहाँ तक तो हमने किया divisibility by 11. Now we need the divisibility by 8. Divisibility rule of 8 says that the number found by the last 3 digits should be divisible by 8. So here the number found by last 3 digits is 4, 6 and b. It should be divisible by 8. So if I divide by 8, what I will get is 8 5s are 40, right? 6 is the remainder. So this has to be 4. Only then it will become 64 and I will get 58 as a quotient. That means this value of b should be 4 only. It can be 4 only. If the value of b is 4, then 4 minus a is 1. So value of a will become 3. And question is asking for b into a. So answer is 4 into 3, 12. Very good, Manvi, Saurav. Answer is 12. Is that clear now? Okay, so let us now check the next one. The next question is again almost of this type. Try this one. You have to now check the divisibility rule by 9, which again says sum of digits should be divisible by 9 in order to get the number divisible by 9. So how many pairs of a and b are possible in this case? Now Saurav, check again. Divisibility of 9 says sum of digits should be divisible by 9. So what is the sum of digits here? 2 plus 4 plus 5 plus a plus 6 plus 7 plus b. So what is the sum? It is 24 plus a plus b. Am I right? this is the sum of digits here. Okay, Sanjeev, let's see. So 24 plus a plus b is the sum of digits. Now, as the number is divisible by 9, that means sum should be divisible by 9. That means this 24 plus a plus b should be divisible by 9. So we are adding something to 24. So what is the number after 24 which is divisible by 9? That number is 27. That means this sum should be, sum of a and b should be 3. Only then 24 plus 3 becomes 27. So this a plus b should be 3. Before I move further, I just want to confirm one thing. Is this clear? Ishan, you are answering for this question or the previous one? Is this clear up to this point? Right. So if you take a plus b to be 3, this sum will become 27. After 27, the number divisible by 9 is 36. Number divisible by 9 is 36 also. How will you get 36? You will get 36 if your a plus b is 12. After 36, it will be 45. And you will get 45 if your a plus b becomes 21, which is simply not possible considering that a and b are digits. So sum of two digits can be at max 9 plus 9, 18. It cannot be 21. At max, it can be 18. That means 45 is simply not possible. So we have two cases here. Either this a plus b, sum of the a and b will be 3, or the sum of a and b will be 12. So we have two cases here. So what are the possibilities? A and b. I can take a to be 0, b as 3. I can take a as 1, b as 2. I can take 2 as 1, b as I can take a as 2 and b as 1, or a is 3, b is 0. So there are four possibilities for a and b in this case. On the other hand, when a plus b is 12, I cannot take a to be 0 because in that case b becomes 11. I cannot take a to be 1 because in that case b will be, if I take a to be 0, b 12. If I take a1, b 11. Not possible again. The maximum value that b can take is 9. So it will be 3 plus 9, 12. It could be 4 plus 8. It could be 5 plus 7. It could be 6 and 6 also. Nowhere it is written that a and b has to be distinct. It could be 7 and 5. It could be 8 and 4, 9 and 3. So how many possible values are there? 1, 2, 3, 4, 5, 6, 7. So 7 cases are possible here. So 7 here and 4 here. Total pairs are 11. So 11 values are possible. It is nowhere written that a and b are distinct. So 11 values are possible. Please confirm if this question is clear. Good. Now try this question on average. So you know the concept of average. Average simply is sum of terms divided by number of terms. Sum of terms divided by number of terms. So this is the formula for average, and we can also say that sum of terms is equal to average into number of terms. Sum of terms is equal to average into number of terms. You can also use this result. Now try to solve this one. Right, Sanjeev? Batsmen score 10, 20, 30, 20 in the first 4 innings. In the fifth inning, the score is 35. So what is the average? So we need to add up all these values. Average is sum of terms. So what is the sum of terms here? It is 10 in the first inning, 20 in the second, 30 in the third, 20 in the fourth, 35 in the last inning. If you add up all these values, 30, 60, 20, 80 and 35, sum becomes 115. So what is the average? Right, Manvi, very good. Average is the sum of terms divided by the number of terms. So terms are 5. So answer is 23. Right, Ishan. Average marks of a class of 40 students was calculated to be 62.85. It was later discovered that the marks of a student were taken to be 48 instead of 84. We need to find the actual marks or the real marks, average marks of the class, real average of the class. So average of 40 students is calculated to be 62.85. I can use the direct method here also. But if we go by the long method, we know that just in the previous slide, I wrote down this formula. Average is sum of terms no Sanjeev. Yes, right, right, Sanjeev. Sum of terms divided by number of terms. Right. So sum of terms is average into number of terms. Sum of the terms, right, Saurav? It is equal to average into number of terms. I can use this result, although I can use the direct result also, but since we have not studied that, I will make use of this result. Sum of terms is equal to average into number of terms. Very good, Saurav. Sanjeev, right? So what is the sum of terms? Initially, the average is 62.85 and number of students or number of terms 40. So total would be, total is average into number of terms. This is the total. Now I am not solving this result. I am not multiplying these two terms. Right? Average is 62.85. Number of terms are 40. So total is 62.85 into 40 means average into number of terms. Now what happened is that the marks of one student were taken to be 48, but his actual marks were 84. Now to get the actual sum, what I'm going to do is I'm subtracting this wrong marks of that student from the total and adding up his actual marks. That means the total now becomes 62.85 multiplied by 40 plus the difference of these two is 36. This is the new total. Please confirm. Is this clear up to this point? Since the 48 marks were the wrong ones, I just subtracted those marks and added the actual marks. Or you can directly add 36, right? So this is the new total or the actual total marks. Average is again the total marks divided by, means sum of terms divided by total terms. That means this new sum, this new total should be divided by the number of terms which are still 40. So I can write it like this: 62.85 multiplied by 40. I can break this numerator plus 36 by 40. This will be cancelled. I'm left with 62.85 plus 0.9. Answer has to be 63.75. Please confirm this one. Is that clear? Or we can directly say that since there are 40 students in the class and the marks of one student were taken wrongly as 84 instead of 48. So if I consider the actual marks of that student, the marks of the student will increase by 36. That means one number among the 40 numbers will be increased by 36. So if one number is increased by 36, then what is the effect of that increase over the whole average? That is the question. So whenever there is a change, there is a decrease, there is an increase in one number, then that change, whether it is increase or decrease, will be distributed over all the numbers equally. And whatever that distribution is, the average will change by the same magnitude. So here the student the marks of one student are increased by 36. So this increase of 36 will be distributed upon all the 40 students. That means everyone will get 0.9 marks extra. So since every student now is getting 0.9 marks extra, the average will also increase by 0.9. So new average would be 62.85 plus 0.9. So answer will be 63.75. You can use directly this result, right? Although the complete method is this one, but when we do this question in the classes, we do not go with this whole concept. We just try this one, that whatever the increase or decrease is there, that increase or decrease is completely divisible or distributed on the on all the numbers, and whatever every number is getting, the average will change by the same magnitude. Is that clear? Let us check the next one now. Average weight of a group of 20 persons was 26 kgs. When a person having a weight of 14 kg was replaced by another person, average became 27.25. Find the weight of the newly included person. No, Sanjeev, this is the increase actually. Okay, let us solve this question directly by the logic itself. It says average of 20 persons was 26. No. It cannot be lesser. Average of 20 people is 26. Right? This is a number. This is the average. Now, what happened? A person with a weight of 14 kg was replaced by another person. Now, what happened is number of people they remain same, but now the average instead of 26, it became 27.25. So, what is the increase in the average? Increase is of 1.25. If the average increased by 1.25, can I say the total will increase by, if average increased by 1.25, can I say the total increased by 20 multiplied by 1.25 or 25 kgs? Please confirm this. If the average increased by 1.25, that means total increased by 25 kgs. That means what happened? We had some total, we removed one person, we added a new person, and the total became x plus 25. Total increased by 25. Did you get this? Let me write it once again. Let us say the initial total was x. X is the complete total. We removed a person having weight of 14 kg. A new person came whose weight is, let's say, y. Due to this replacement, the total weight increased by 25 kgs. Initially it was x. Now it became 25 plus x. This x cancels. The value of y becomes 39. That means the new person that is coming in the group is of 39 kgs. Now what will happen? The person whose weight was 14 kg, that is being removed from the group. So when the new person will come, what will happen? First of all, he will compensate the loss done by the removal of the person. Since the 14 kg is the total loss when we remove the person, so the new person will first of all cover that loss. So first of all, he covered that 14 kgs, and the leftover part, which was 25 kgs, that was now distributed among all the people equally. That's why everyone got 25 by 20, means 1.25 kgs each, and average increased by 1.25 kg. So earlier it was 26, now it became 27.25. So answer has to be 39 kgs. Please confirm, is that clear? Although you can solve this question by the other method also, which we discussed in the previous example. You can solve this by that method also. But please, just I want to confirm, is whatever I have done here, is that clear or not? Okay, Manvi, let me once again explain. Is that clear that this 25 kg is the total weight increase in the group? This 25 is the total increase in the group. Manvi, is that clear? Now, let us assume that before the removal of this person, which has a weight of 14 kg, before the removal of this person, let's say the group has a weight of total weight of 14 kgs. Oh, sorry, total weight of x kgs. Before the removal of this person, let's say the total weight of all the 20 people was x. What happened? We removed that person of 14 kgs. We added a new person with weight of 20 with weight of y kgs, and the end result is that the total increased by 25. Initially the total was x. Now that total becomes 25 plus x. Manvi, please confirm, is this equation clear? Now you can solve it. Done. Y is 39. Y is, what is the y? Y is the weight of the new person, that is 39 kgs. So this is all about from my side, and I hope that the concepts that we discussed in this session, you people are now able to solve the questions based on those concepts, whether they are the basic concepts on the definitions of the numbers or the divisibility rules, etc. Any other doubt in your minds? If you want to ask anything else, you can ask them. Yes, Saurav, please. Okay, last two digits of 7 power 2008. Right. So 7 power 2008. So if you want to find the last two digits of this number, just check the cyclicity for the last two powers of 7. 7 raised to power 1 is 7, which is 07. 7 square is 49. 7 cube is 343, which can be written as 43. Since I am only interested in the last two digits,
Yes.
7 power 4 is 2401. That means I am only interested in 01. 7 power 5. Obviously, 7 power 4 is 2401. So 7 power 5 will be 2401 multiplied by 7. So at the end, you are again going to get the last two digits as 07. So basically, you can check that 07, 49, 43, 01. Again, you get the same last two digits which were in the first step. Okay, so that means this cycle is of just 4 steps only. After that, repetition of last two digits will be there. You can check that on your own, that if you multiply this number, this will be 70, right? After that, when you take 7 power 6, you have to multiply it by 7. Again, it will be 49 at the end of this number. So you will get 7, 49, 43, 01, 7, 49, and so on.
Yes, sir.
Right? So cyclicity is just 4. So that simply means whenever you have in the power of 7, 4, or a multiple of 4, that means you will get 01 at 7 power 4, you will get 01 at 7 power 8, again 01 at 7 power 12. So whenever there is a multiple of 4 in the power of 7, the last two digits will be 01 only. Here again the power is 2008, which is a multiple of 4, right? So last two digits are going to be 01. Answer to this question which you have asked is 0 and 1. Okay, so what we generally do is we divide the power by the cyclicity and check the remainder. If the remainder comes out to be 0, we consider the last step of that cycle. The last step in this case is 0, 1. So answer would be 0, 1. Now let us change the power. Let us say that instead of this 2008, the power is say 7 raised to power is, let's say, 2003. Again, cycle will remain same. Cycle will not change. It is still of 4 steps. So what we'll do is we will divide the power by 4 and check the remainder. Now you can see that if I divide 2003 by 4, the remainder is going to be how much? 3.
3.
So 3 means you are now on the step number 3. So what
43.
is in the step number 3? It is 43. So that means the last 2 digits of 7 power 2003 would be 43. Is that clear?
Yes, sir.
Any other doubt?
No.
So I think with this, I will wrap up the session, and I hope to see you people in the actual classrooms.
Yes, sir.
Okay, thank you. Thank you to all of you, and have a nice day.
You too, sir.